So finally, we are gonna learn dynamics. So welcome to the new level, dynamics. So which is inside object and geometry, and here dynamic level. So welcome. This dynamic level, that's where all the simulation happens. So simulation is nothing but the moving object, not animating, it's moving whatever. So all the fluid, fire, distraction, everything will be held inside this level called dynamics. Okay, so if you right click, you have a different tab menu than what you see in the geometry level or in the object level. All right, so first we're gonna start from the pop. I'll tell you what this node is, but just an introduction. Pop means particle operators. So what is particles? Particles is a point which moves through space. So which means this one. So if I play, you can see particles are points and the points are moving through the space, and I'm not doing anything. It's like I'm not animating or anything because it has a simulation in itself. I hope you understood what is pop. So I'll delete this geonode and I'll create a new one so that you know that I'm starting from scratch. Okay, and intro to pop. So earlier version, which is Houdini 16 and older, there is no chance for you to do simulation inside geometry level. But after 17 and after the introduction of Vellum, they changed their rule and they broke their rules some here and there, which means you now can do simulation inside geometry level. Okay, it's like you can do pyro simulation, RBD, and Vellum simulation inside geometry level, but not pop network particles. I'm just giving you the new updates. It's like earlier I could say that you cannot do dynamics in the geometry level, but now that I cannot use that word anymore because now you can do simulation in the geometry level as well, right? So how do we start a dynamic? Okay, how do you get inside the dynamic level? For that, you have a node called pop network. So you can see a lot of networks here, and I don't know why side effects didn't add pop network in here, but instead they kept the pop network inside the utility. So you can see pop network. So before double clicking it, I also want to show you so what it is. You can see here dop network. You see here the node name is dop network. So you can find the similar thing in the manager dop network. Okay, so it's both the same. It's like you look at the logo, look at the icon, everything is same, and even here it's dop network and dop network, and here dop network, but it is written as pop network. So which means both of these are same. So that's the main point. Pop network and dop network are same. Inside dop network there's only output. Okay, and inside pop network there's already some preset or like pre-made setup. So this is what we're gonna start from. We will be handling with the dop network later. I just wanted to say that this pop network is not a pop network, it is actually a dop network, and so just want to say that exists. Okay, so I'll delete the dop, right? So pop network, this thing what you see is not a shelf tool kind of. It's like it is not linked to anything, it is all empty. It's like it's all default setups. Houdini is trying to give a ready-made setup, so that's the only thing. So let me explain about what is going on here. So pop or any dynamic need a source and need an object, and of course the very important thing is need a solver. Call it anything. You are doing a pyro, or like if you are doing a smoke, or if you're doing a fire or distraction. So if you right click, you can see here solvers. So you see these are the solvers that you need, right? So all these solver are the engine, I would say. So solver is the engine of a car, you can call it. So engine of a rigid body or the distraction is this one. The engine of cloth and soft body is this one, and same with pyro is for fire, is the engine of fire. So same like that, you have particle solver, so where the engine of particles. So you see here it's exactly the same, and it of course it has a 3 connection, and one, if you mean the middle, if you come across here, you can see is the source post solve, and this is pre-solve, and this is object. So this is where all are calculated. So I'll give you a easy way to recognize, or like to understand what's going on. It is just my way of understanding. Okay, so imagine this as a car. Okay, so it's the complete car. So where object behaves like tire or body, and source behaves like gear or steering wheels. Like without a steering wheel or gear, you cannot move a car, right? So if this is like more of a direction, the gear, steering wheel controls the speed and the direction, isn't it? So same with the pop. So this side, so not only the source, I'm talking about even this one. Okay, so this side is basically a gear and steering wheel, where you add speed and control speed and control direction and all sort of that. Okay, and where object is just the body and the tire. So when you apply brake, so it's like should it slide? So tire, so should it slide or just stop there? Okay, so that all decided this one. So basically you don't have to do anything in the pop object, you kept it that way itself. The part is where you control your speed and direction. That's the only thing you need to take consider. And now we have a tire, body and gear, steering wheel and stuff, and it doesn't complete a car, right? So for car you need an engine. So this is the engine. So you can call it, this is a pretty good engine. So you can say that Audi V8 kind of engines. Like everything is already there in the pop solver. So there's only few times that you need to take consider of pop solver. So other than that, in the most of the cases you won't be touching the pop solver and the body. Like all you will be handling only this side. The rightmost side is the only the thing you will be going on so much. This is nothing, it's a merge node. As a ready-made setup, they are just giving us that merge node just in case, like you can connect. That's up to you. The merge node is just giving you some kind of help in case you need it. Basic workflow you need to know or remember when doing dynamic simulation or pop simulation. Okay, so first thing you need to know is you need to have a source. In other words, you need to have a driver, right, for riding a car. So you need to have a source in Houdini. Okay, so source can be brought in the dynamic itself or in the geometry or SOP level. Okay, so I have a geometry, this guy, and I will bring him. We will use, okay, so that it stays on the ground, just like that, my personal preference. For the training, what I'm going to do is I'll just take this guy's eyes as my source for emitting particles or generating particles. Like this is where the particle has to come out. Okay, it's just that's what I'm trying to do. You can either select by manually, or what I would do is, I know this pig head has separations. Like if you middle mouse click it, you can see there are plenty of group, eyes, face and stuff. So I'll take only the eyes. So group selection and eyes, and then I will delete it. I'll press the button delete. So I have that blast and the group is selected. So I'll just take only that, right? So this is what my source. So the next step in the source, we took B so which is like we are taking it from the SOP level. I'll show you in the dynamic level, but let's do the SOP and then quickly show you pop. In most of the cases, we will be having source from geometry. Very hardly we take source from the dynamic. We will hardly take a location. So I'll tell you what it is. And the next step is in the pop source. In the pop source, we have to say that it's like we right now we have it as geometry, but we did not connect anything to the dynamic, right? So there are plenty of options to source it. So to source this means like to read it. It's like, so one method is you can come here, you can see input 1, input 2, 3 and 4, right? So you can connect it to anything. So I connected the first geometry, and in the pop source, so I'll delete, I'll bring that again. So it's the basic setup, I just brought it, and in the source, now the second step is like once you have the source in the geometry level, once you fixed, you know, A or B, I choose B. So in the source we need to say where it is coming from, where is the geometry source. Okay, so if you come up here, you can see first input, second, third, fourth. So you can select that way. So, the source can be from the SOP level itself, right? So it need not to be here. You can also bring it if you have something over here in some other and you have a name, of course. So in some other, then you can even take that as your source inside the pop source by going here in the parameter value. So avoid this DOP object for now. Okay, so use parameter value and then you can go select your source. Okay, so you have two methods to select it, right? So I'll delete, I'll delete this example, and I'll take the first content geometry, right? And the next step is, you see we have the source, we took the first geometry, and the next is emission type. So what's the type you wanted the pop to emit? Okay, emission, the emission type, right? So there are 4 types: all point, all geometry, point, and scatter on surface. For now I'm going to select all point. Okay, all point. So this is my eyes. So I'm taking the all point. So all point means whatever the points are here. So you see 90 points, isn't it? Or you can see here, yeah, so it should be 90. Okay, so take these point, that's what all point means. All point means whatever in the geometry level points are, take that point as your emission type. Okay, I will go through the other one, but first we will do the workflow setup first. Okay, so we have the points, and then what's the next step is, once you have the source, you know, B, and you took the so where the geometry is coming, and then in the geometry what is that you want to take. So I said all the points, and then birth. Okay, so next we need to say birth. So like when to born, you know, when does the point has to be born, and how many has to be born, and how long has to be born. Okay, so to do that you go to the birth. So as we choose all points, you can see there are many things that is grayed out. Okay, so that's because we are saying there are 90 points, isn't it? So when there is 90 points, then you don't need to do any counts, isn't it? So that's why. Okay, so this is, well, I'll tell you what is impulse activation and constant activation in a bit. But before that, I'll just cover all the steps that you need to do. So the first question is when to born. So here it says 1, so which means 1 frame, so which means every frame it has to be born. 10, so there are 90, right? So 90 particle to be born on the first frame, and second frame, third frame, 90, 90, 90, 90, etc, etc. And how many, so we know that we said 90, so 90. So that's why like if we're taking points, then you can control, okay, you can control all these. But I'll start doing that. First I will explain on the all points. Okay, so and the next question you should ask yourself is how long you need to your particle has to bond. Okay, so you come up here, leave this series, nothing but distributing the shuffling the points, and life expectancy is what, how long you need to live. So if you keep your mouse here, you can see how long the particle will live in seconds. Okay, so this means is 100 seconds. This is not frame, this is 100 second. So you need to know one thing, that 24 frame, so whatever you choose here, okay, so frame per second is 24. So this is the default setup, so that's why I'm saying 24 is the, if you keep it 30, then 30 is the 1 second. Okay, but as a default it is 24. So 24 frame is 1 second. So it's like 1 2 3 4 5 6 7 8 9. So just 9 seconds. So imagine here it says 100 seconds, so it could be 2400 frames. Okay, so you can control that. It's like you can say, oh no, only be born, or like you have a life of 1 second. Okay, so which is 24 frames, so it's gonna die after 24, right? So I'm not playing the simulation yet because I wanted to show you this workflow, so which will make it easy for you next time when you are trying to do pop. It's like, first thing you need to know is you bring a source and a geometry source it and emission type, then control the birth how you want it to be, and next is dynamic. So dynamic, or other words, it's called force related to motion. Okay, so now is the one that like we need to apply a force, right? Force or velocity in order this to work. Pop source. So first there are three methods for bringing the dynamic, like velocity or force. You can bring it in three method. So one is pop source itself, so which is the topmost node, pop source itself. You can bring the velocity or force. Basically in here you can only bring velocity, right? So and the next is inbuilt forces. Okay, and which means there are in Houdini itself has a nodes, like plenty of nodes, these many nodes. I'll show you how. It's like there is inbuilt nodes that you can use it for manipulating the force. Okay, so that's the next method of when you're doing you can think of. So third method is you bring in geometry level or SOP level. You can bring the velocity in the SOP level. Okay, and the fourth is all. You can mix all these three and get a force. Okay, so I'll start off with the pop source itself, like the velocity which is coming from the pop source. So if you come here in the pop source, I covered the source. There's nothing much important here, and the birth, like since we have all points, many of these are grayed out. Okay, and we have expectancy, and in the attribute, so in attribute you see here initial velocity. So right now it's use inherited velocity. So inherited velocity means the velocity which is coming from the geometry level, which means the last one. For as a default it is looking in the geometry level, but we can say that no, we have a initial velocity, and in the middle you can see add to inherit velocity, which means the whatever you have the velocity which is coming from the the geometry level. So geometry level, wherever it is coming from the geometry level, you can add here. It's like if in the geometry level the velocity is 1 in the x-axis, then you can bring 1 here, so it will be adding 1 and 1, so 2. I will explain with the example, right? So first we will start with initial velocity. So we are saying the first one, the pop source itself, we are trying to bring the velocity. Let's see what it's gonna do when you have used inherent velocity. So I told you there is nothing coming, no volume or no velocity coming from the geometry level. It's like if you middle mouse, no velocity or force, just the position. So you can see when you hit play, you see you don't see anything. That's because it is looking for velocity in the geometry level, right? So now you can now if you select the set initial velocity and you keep in the y-axis, so I'll tell you what is velocity and stuff, but just before that, I just wanted to show you something and then I can explain more. So in the velocity y, so I'm putting one y, which means up, negative will be down, so 1y, and if I click play, okay, so if I click play, you can see it is going up. Okay, that's because I said the velocity is 1, so 1 is applied to all the points, so that's why it's going up. Okay, so if you say to the x, so x will be this side, because you see here x, so x is this side. Okay, so I'll clip 1 here and let's play. You see 1 1 in the up 1 and the x. So this is what, so you can do all of this. And what is variance? Keep here, you can see that variance means plus or minus, so plus or minus to the velocity. So if you keep here 0.1, then what it's going to happen is it's going to add or minus the velocity here. So it's like x, there will be x minus 0.1 and plus 0.1. Okay, so that's going to happen here because it's going to add or minus with the velocity up here. Okay, so you can see here's little variation happening. You can see little variation happening on the x and minus x, just a point difference. So if I keep it 6, so it'll be 6 or minus 6. Okay, so it'll be we'll be having a very big stretch. You can see here, you see the x-axis, 6 variance is happening in the x and minus x. Okay, so accordingly that you can do here also. It's like, so basically what when we'll be using is, it's like right now you can see it is going straight, isn't it? It is going straight. So but you need a little bit of variance in the all axis, then you can keep maybe 7 or something, just a slide, and then you can see, yeah, it has a variance, and now it behaves more of like a water, right? So that's what variance is. Whenever you see variance, it means plus or minus with the velocity or whatever in the up. Okay, so now if you middle mouse click the pop solver, it's like if you come here, middle mouse click, there's only P. Now it has a dynamic, and in the solver there are plenty of, like, you middle mouse click it, then you can see age. If I play and stop, yeah, you see there is age attribute, the new age attribute, dead attribute, ID, life, and velocity. So we have a velocity, so all of that. Okay, so I'll just give you a quick intro on velocity. Some people who are not familiar with science might feel confused with velocity and speed and acceleration and all. So I'll just explain what is speed, velocity, and all in a very quick way. If you have a doubt what is speed and what's the difference between speed and velocity, so I'll give a quick and easy understanding of speed. Means it's like 4 Mbps. Okay, so which means like 4 MB per second, isn't it? So every second it's gonna copy 4 MB, isn't it? Or in other words, if you have a downloading speed of 100 Mbps, which means so you can download 1 GB data in 10 seconds. That's because you have 100 MB 100 MB per second. So 10 second you will have 1000 GB. So that is speed. And velocity is the same theory. So here I will introduce as a with the car. It's like why car and why not speed has a car explanation. I'll just give you so I'll make it so clear. It's like velocity means it is just like speed only, but with a direction. So in here in the copying you can see it doesn't have a direction, it just speed and finish it, right? But velocity means it has a direction. It's like when you are going from one town to another town, you have a direction, right? It's like north, east, west. So that is basically called velocity, right? So velocity is nothing but speed with a direction. So in our Houdini, velocity is a vector, of course, because it has a direction. So you can see here it has a direction x, y, z, right? So that is speed and velocity different. And now I want to talk about what is acceleration, because in Houdini also we will be using the acceleration also. So acceleration is nothing, it's the change of velocity. It's like I have a car here. So you see here if a car has a speed of 30, okay, so 30, and as it reaches the curve, it will slow down, isn't it? And then again it will speed up and then pick to that this 30 kilometer a point. So change of velocities, like when it is 30 here, but as it come here it's going to slow down. So slow down is called changing the velocity. Again, what's happening here is an acceleration. It's like change in velocity. So acceleration is nothing but change in velocity. Imagine this picture while doing acceleration attribute or something. Okay, so that's the difference between speed, velocity and acceleration. Okay, so it is not the same, but it sounds the same. So now I believe you understood what is velocity and why it has XYZ axis. Let's get back to the source itself. So right now we have all point. So I'll just explain I'll explain what is happening. Okay, so you can see here, so as I explained, there are plenty of attributes coming when dynamic is happening. Okay, in the source, when you put all point, impulse is 1, and I'll show you what is happening here. So it's like in the first frame, if you middle mouse click it, it will be 90 points, which is actually coming from here. Okay, 90 points, right? So what's happening here is like every frame, it's like if you go second frame, if you middle mouse click it, you can see 180 points, because in the source we have 90. Okay, and it is generating every frame. Okay, so if I'm wrong, you can go to the I'll go to the 10th frame. So 10 into 90, so it will be 900. Okay, see, 900. All right, so that's what impulse activation and all point is. So this activation is basically, it's like, it is not number, it is not, I don't know why they keep it as a slider. It should be probably, you know, like a tick, on or off. So it's like 0 is off and 1 is on. So that would be better in this case. Okay, it's like on and off. If I put it 0, then it won't, there's no simulation happens, because the activation is off, turned off. So right now it is on. Now we'll be having it. And yeah, you always keep in the real time toggle. It's like if you don't keep the real time, it just go faster and it try to show you as fast as you can. But if you keep it here, it's going to show you real times. Like this will be 1 second. If you keep your clock, it'll be like 2 seconds. It'll be exactly how it is. So 1 second, 2 second, 3. Okay, so that's how it's going to go. So keep in real toggle on when you're doing a simulation, so that you get accurate timing. right? So the next one I want to show you is all point. Is that's the thing, nothing